Hello everyone, this project presents a new robotic surgery remote mentoring via augmented reality, with 3D scene streaming and hand interaction. We are honored to be awarded as the first runner-up on the scientific pitch of the 5th Hong Kong Innovation Day. As we know, robotic surgery is increasingly adopted in clinical practice, and its market size is exploding. This trend brings about urgent need of enhancing surgical education for young surgeons, in order to overcome the difficulties of demanding surgical skills, long learning curve, and safety risks of this new technique. Remote mentoring is prominent for surgical education. It can address the lack of experts and imbalanced regional distribution, as well as reduce traveling cost. The current solution for teaching is online video streaming, as shown in this picture. Remote experts watch the broadcast video and give voice instructions. Despite being useful, such a style has limitations of low interactivity, not intuitive, and hard to communicate when encountering some complex situations. Therefore, to solve these limitations, we propose a new solution of remote mentoring, by developing an augmented reality-based paradigm. Specifically, in the operating room side, the young surgeons see the surgical field of view in the console of Da Vinci Robot, and this surgical view can be compressed and transmitted out in real time to the remote expert side. The expert wears an AR glass, such as HoloLens, to visualize the reconstructed scene in 3D. Furthermore, he can also demonstrate the surgical actions, such as suturing trajectory with pure hand interaction. Then, such demonstration can be transmitted back in a closed loop, for direct and precise guidance inside the console. As shown here, the young surgeon can basically follow the clear demonstration to complete the task. The key methods to achieve this include 3 parts. First, is the efficient reconstruction algorithm for surgical scene streaming. It first estimates the depth from stereo robotic videos and generates RGBD images, which are then compressed through the JPEG algorithm and streamed to the mentor side. Second, is the head-mounted display visualization and hand-based natural interactions. It will visualize the surgical scene as point clouds and estimate hand pose, and perform coordinates transformation to align the physical and virtual spaces, so that the mentor can perceive the 3D surgical scene and then provide surgical guidance using hand gestures. Third, is the efficient guidance compression method. It can convert the 3D surgical guidance into lightweight representations, which are then transmitted back to the operation side in real time for closed-loop feedback. Our hardware setup consists of a Microsoft HoloLens 2 on the mentor side, a Da Vinci surgical robot on the men side, a Wi-Fi router for network communication, and a computer for AI computing. Through the network, the surgical scene can be streamed from the Da Vinci platform to the HoloLens 2, and the surgical guidance can be transmitted from HoloLens 2 to the Da Vinci platform. We simulate the real surgical scenario by playing back the recorded stereo surgical video. Here we present an example of the robotic prostatectomy procedure. As we can see, the mentor is manipulating the virtual needle, and drawing the suturing trajectory, which is streamed to the operation side for guidance. Moreover, we also conduct a quantitative evaluation of our system. Here we study the inference speed of the entire remote mentoring paradigm at different video resolutions, and the user experience of both the mentee and mentor sides from multiple aspects. Results demonstrate the efficiency and effectiveness of our system towards real clinical applications. Compared to the previous on-site solutions, our proposed remote mentoring system has higher efficiency. Meanwhile, our system has a lower cost using the head-mounted display instead of using heavy physical input devices and monitors. Besides, our solution is more interactive with AR glasses, in contrast to plain 2D screens. Furthermore, our system supports straightforward 3D guidance, yielding a higher precision compared to using voice instruction. Last but not least, our system can enhance surgical safety and finally improve surgical outcomes. Thanks for watching our video.